Next is charge and colloidal particles. These particles are having some charges, either positive or a negative charge on this. This particle is because of the electron ion goes and settle on them. So, let us take one example and study. If AgNO3 is taken and treated with potassium iodide, silver iodide is formed. This silver iodide attracts one more ion on it. Suppose if it attracts iodide ion on this, then the soul gets negative charge. If there are one more possibilities, if I add potassium iodide to silver nitrate solution on this silver iodide, silver ion may go and deposit. When this iodide has been deposited, this layer is very firm. So, due to this firmness, it is also called as fixed layer. This fixed layer is nothing but the first layer. Now this fixed layer counter-ions one more ion. If it counter-ions one more ion, it will be a positive ion. This is a second layer. Second layer is mobile. Due to this mobile nature, I can call it as a diffused layer. These two layers, the first layer and the second layer together, it is called as Helmholtz electrical double layer. Helmholtz electrical double layer. These two layers, if I want to remove, these are having different potentials. The difference in these potential energy is only called as zeta potential. So let us write the definition of this. Zeta potential, or also called as electrokinetic potential. The potential difference between the fixed layer and diffused layer is called as zeta potential. After this, we are going to study next property. Next is coagulation of particles. So here what happens is precipitation occurs. The settling, as we are studying, colloidal particles are in continuous motion. The settling of particles is only called as coagulation or precipitation. So, settling of particles or coagulation or precipitation. precipitation. This can be done in few steps. If electrophoresis is done, we are going to do this next. Electrophoresis. One more is by boiling. You can precipitate it by adding different charged salt. Also can be done by adding small amount of electrolyte. So these are the things. Also one more thing is that called as persistent dialysis. Let us study one by one. Electrophoresis we are going to study next. Then I will tell you how it works. Next, second one is boiling. By boiling, what happens? What we said now, the charge is because of electrolyte going and setting. Electrolyte ion going and settling on the colloidal particle. Because of that, there is a charge. If we boil, what happens? The charge gets kinetic energy. When it leaves the surface, the charge is removed from the colloidal particle and the particle coagulates. Next is a charge by adding a soul. If the soul is having positive charge, then the soul having negative charge is added so that neutralization occurs and precipitation happens. Next is by adding electrolyte. If the soul is having positive charge, then an electrolyte which will assume negative charge is added. Next is persistent dialysis. If dialysis goes on for a longer period, then all the electrolytes are removed from the colloidal soul and then the particles will lose the charge and precipitation occur. Next we shall move on to this electrophoresis. I will discuss this thing. Next property is electrophoresis. Your apparatus is taken. This electrophoresis is done to confirm the charge of the particle. U-shaped container we have. This apparatus is having a reservoir. This reservoir is connected to a stopper. The electrode are connected. These electrodes are nothing but platinum electrodes. And then colloidal solution is added in this. And these are connected to a battery. Suppose this is cathode electrode and this is anode electrode. And if this colloidal solution is having positive charge, then all these ions, all these particles will move to the opposite charge of electrode. So what is electrophoresis? Movement of colloidal particle to opposite electrodes. Here we have taken an example of electrophoresis. What happens here? By the electrophoresis, all the charges particles are removed, then the colloidal soul will not have any charge and coagulation occurring. After this, we are going to move on to the next thing called as Coagulation of lyophilic soap. Lyophilic salts are very stable. This stability is due to two reasons. One is because of solvation and other one is because of charge. If these two are removed, then coagulation occurs. How to remove these two? These two can be removed by adding electrolyte or by adding solvent. Solvent such as acetone or alcohol can be added. Solvent such as alcohol or acetone is added. What it does is it dehydrates the dispersed particle. On a dehydration, the coagulation occurs. One more thing we have to study called as protective colloids. Thing is protective colloids. The lyophobic salts are very unstable. So, to make it stable, we can add lyophilic salt. What lyophilic salt is, it makes an cover, protective cover on the lyophobic salt. So, this lyophilic is called as protective colloid. What happens here is lyophobic is unstable. So, lyophilic added in it makes the protective layer on the lyophobic. So, lyophilic is called as protective colloids. One more new term we are going to study called as Hardy-Screw's rule. It says nothing but if the charge of flocculating ion is larger than coagulation is greater. For example, if aluminium ion we have, then barium ion and then sodium ion. So in this aluminium will have greater flocculating capacity than barium and sodium. One more example we can take. If we take FeCl6, the charge on this is 4 minus. Then if we take phosphate, then we can take sulfate and then Cl minus. If we take, these are having greater capacity to coagulate due to larger charges. After this, we are going to study the next thing called as emulsion. These emulsions are nothing but, in this, both the dispersed phase and dispersion medium are liquid and they are immiscible. Immiscible or partially immiscible. we can take down the definition. 2. Immiscible liquid or partially miscible. Next, what we are going to study is types of emulsion. We have two types. One is oil dispersed in water, and another one is water dispersed in oil. It is also written like this: oil dispersed in water and water dispersed in oil. Here oil is dispersed phase and water is dispersion medium, whereas here reverse of water is dispersed phase and oil is dispersion medium. Here you can take an example of milk, and here we can study the example of butter. What happens here in oil dispersed in water is this is very unstable. If you take an example of milk, cream, you feel like when you heat it, you feel like the cream has dissolved in the milk, but on standing or cooling again it separates. So for such kind of substances, to make it stable, an agent is added. That agent is called nothing but emulsifying agent. After this, we are going to study all the kinds of colloidals around us. So around us, what kind of colloidal particles we are seeing? Few examples are here. One is blue color of sky. And one more, we have the formation of fog and mist. Then blood coagulates, so that we are going to see here how it coagulates. Then we have let us move on to the first one, blue color of the sky. Blue color of the sky is because the sun is having all the colors. That sun rays, the light when pass on the dust particles, large area is there. So all the light are being absorbed. There in this atmosphere there are nitrogen and oxygen also. It is smaller in size. When these rays fall on this nitrogen or only on oxygen, smallest wavelength is absorbed. That is a blue color or violet color. But our eyes are sensible only for blue color. So we can see blue color of the sky. Next is fog and mist. Fog and mist, how it happens? In the atmosphere, the dust particles are cooled down at a dew point. After cooling, the moisture from the air goes and condenses on them. These are colloidal particles. So, these float in the air. As these float in the air, it forms fog and mist. Next is blood. When there is a cut or wound in our skin, what happens here is coagulation occurs. It is because of static action of ferric chloride and alum. After this, we shall move on to the application. In application, we are going to study two things. One is smoke precipitated. an apparatus is inserted in the chimney. What chimney does in the industries, it lets out all the kinds of gases. So, before letting out in the atmosphere, these are treated. So, we have an apparatus called as Cottrell precipitator. Here is an outlet for the gases, and here smoke is allowed to pass. These are having chambers. This chamber is having the plates which are charged, and this high electricity is passed. Gases free from carbon particles, and here all this smoke gets precipitated. How it happens? The smoke is allowed to pass in this Cottrell precipitator. These are having the plates. These plates are charged. The charge is opposite to the smoke particles. Due to this, there is mutual neutralization. When there is neutralization, due to this mutual coagulation, precipitation occur, and carbon is removed from the gases, and gases free from the carbon particles are released. One more what we are going to study is tanning. Tanning is nothing but your animal hides are taken, which is having a colloidal property. Those properties are having some charges. Those charges are removed by putting this hide in the solution having opposite charge. So if it is having a positive charge, it is put in a solution called as tannin, which is having negative charge. Even here neutralization occur, and this hide is hardened. So this process is called as tannin. By here we finished the surface chemistry. Keeping in mind the lockdown situation, teaching of mode I have changed and given you all the kinds of notes along with the explanation. I will give you a few questions for assignment, keeping in view your board exam. You can write the answers for those by watching the videos. So you people don't have textbook, so the teaching is done so that you can, in such a way that you can write your own notes, and questions are given, you can study for this chapter.